Good morning, students. Today in this video I will be discuss the second chapter of class 10th related to chemistry. This is the acid, base and salt. Today in this video I will be discuss regarding acid. What are acid? What are acid and base? Acid and base. If I will be go according to Arrhenius concept, that is a Arrhenius concept, that then the substances which gives hydrogen ion or hydronium ion, that is the hydronium ion by dissolving in water, are called acids, like example, if I will discuss, suppose I have HCl, and if I'm going to dissolve HCl in water, then HCl is going to split up into H positive and Cl negative, so that gives us the hydrogen ion. So I can say that HCl is acidic in nature. The same, if I will be take HCl, it is reacted with H2O, then this H ion reacted with H2O, it will be giving us H3O, already positive charge on hydrogen ion that will be coming on this, that is a Cl negative. This is the hydronium ion. So that meaning whenever any substance give us hydrogen ion by dissolving in water, they are called acids. The same other example I am discussing with you. Suppose I am having H2SO4. If I am going to dissolve H2SO4 in water, it will be giving us 2H positive and SO4 2 negative. That meaning 2 hydrogen ion it is giving us. So that we can say that this is also acidic in nature. Or if I will talk in the case of hydronium ion, then this will be in this way: H2SO4 plus H2O. This will be giving us H3O positive plus SO4 2 negative. It's 2 molecule and it's 2 molecule that will be available there. Then we are getting this. So this is the hydronium ion. So again we can say that HCl, H2SO4, they are acidic in nature. So any substance that will be give us hydrogen ion or hydronium ion by dissolving in water, they are called acid. Now I will be talk about the base. What are base in this? So same, according to Arrhenius concept, the substances which gives hydroxide ion, that is a OH negative, by dissolving in water, they are called base. So that meaning any substance which give us hydroxide ion by dissolving in water, they are called base. Simple example is there. Suppose I have KOH and I'm going to dissolve in water, so this will be giving us K positive and OH negative. So that is giving the hydroxide ion by dissolving in water. So we can say that that is basic in nature. Same, suppose I am having NaOH. This is a sodium hydroxide, and same when I am going to dissolve in water, that is giving us Na positive and OH negative. So same, it is giving us the hydroxide ion. So we can say that that is also basic in nature. So that very simple. Any substance which give us hydroxide ion by dissolving in water, they are called base. Now some indicators are there that will be tell us about the acid and bases. I will talk about the indicators. The meaning is that what are indicators? If I will talk about the indicators indicators. So what are indicators? Very simple. I will be give the example to you. Whenever we are moving for any journey, so on the road we have seen some signboards are available there. They are indicate that ki our station is that much of kilometer left, now we are moving that direction. So that meaning they are telling us about the our journey, ki by which path we have to move to reach our journey. Same in the indicators in this case, the substances which will tell us about the acid and basic substances by change in color. So that meaning the substances which tell us about acid and base by changing the color, they are called indicators. I will be discuss especially three indicators that are in your syllabus. One indicator is litmus. That can be of litmus paper or that can be of litmus solution. Now if I will talk about the litmus paper or litmus solution, so there are two types of litmus paper or litmus solution. The first is blue litmus. Second is red litmus. Suppose I am having a substance A and I am going to add it there, blue litmus, either the paper or either the solution. If that blue litmus turn into red color, then we can say that this substance A is acidic in nature. So that meaning acid turn blue litmus into red color. So that meaning any substance which turn blue litmus solution into red, they are called acidic in nature. Same, suppose I am adding the substance A with red litmus. If there is no change in the red litmus, then this indicate that A is acidic in nature. That meaning firstly a acid turn blue litmus into red, but there is no effect on red litmus. So very simple, with the help of the litmus also we can give the definition of acid. We can say that the substances which turn blue litmus into red, they are called acid, or the substances which do not show any effect on red litmus, they are acidic in nature. So with the help of this also we can explain about the acid. Same if I will talk about the base, so they are also in the same way. If I am having any base and I am going to add it there, red litmus, if this red litmus turn into blue then very simple, that substance is base, because the substances which turn red litmus into blue, they are called base. And the same thing, base, if the base is there and I am taking here blue litmus, then there is no effect on that blue litmus. So that is very simple. With the help of this we can explain about the acidic and basic nature. That is the one topic, that is the litmus. I am making one chart here. With the help of this chart you can easily understand about the more indicators, and that are important also. They can ask in exam in 1 marks. Like one side, so I have taken the indicator, that are indicator. In the second side I am taking the neutral color of the indicator. Neutral color of that indicator. Then third is I'm taking the colored in acidic solution. Color in acidic solution. And third is color in basic solution. Color in basic solution. Now if I will be taught, so first of all I am taking here litmus. So there are two litmus. One is the blue litmus, one is the red litmus. Actually the litmus that is purple in color. But whenever I will be talk about the special color of the litmus, that is a blue and red. So the neutral color of blue litmus, this is blue, and the red litmus, that is red. Second indicator I am talking about the methyl orange. So methyl orange, its neutral color is orange. Third I am talking about the phenolphthalein. That phenolphthalein, this is the neutral condition, that is a colorless, it does not have any color. Now the point is this, when I will be add the blue litmus in acidic solution, then it turn into red. And in basic solution, the same blue litmus does not show any effect, no change in color. That meaning it remain blue. Now if the red litmus we have, then if I will put the red litmus in acidic solution, then the red litmus that turn into blue. Now if I will be at the red litmus in a basic solution, the red litmus, there is a no effect, it will be no effect. Its meaning it will be remain red in color. Now if I will put the red litmus in basic solution, then the red litmus turn into blue in color. Now I will be talking about the methyl orange. If I talk about the methyl orange, if I will put the methyl orange in acidic solution, then the color of that whatever neutral color of the methyl orange, that is orange, it turn into red in color. So that meaning in acidic solution, the color of methyl orange turn orange to red. But if I will put in basic solution, then its color change to yellow. Same for phenolphthalein. In neutral, its color is colorless, that does not have any color. If I will put in acidic solution, so it will remain colorless. There will be no effect in acidic solution on the phenolphthalein indicator. Now, but if I will put the phenolphthalein indicator in basic solution, then the colorless is converted into pink in color. So this is the one chart by which you can explain the change in color in acidic or basic solution for the particular indicator. So that is very important chart. With the help of this chart, 2 or 3 questions can be asked to you. Like one question is there, what is the change in color on phenolphthalein when it's added in basic solution? So that meaning the change in color is from colorless to pink in basic solution. Same, what is the change in color in methyl orange when it added in acidic solution? Then it turned from orange to red in color. So that meaning this is the very one short question which they can ask in exam. So keep in your mind. For one thing I will be discuss with you here, a short thing, that is ABR. You keep in your mind ABR. A meaning acid, B meaning blue. R meaning red. That meaning acid turn blue into red. It's indicate that ki acid turn blue litmus into red in color. Acid turn blue litmus into red in color. The second point is here. This is B, that is base. BRB. BRB. That meaning base turn red litmus into blue in color. Base turn red litmus into blue in color. So that are the short things, ABR and BRB. So this is very important. Please keep in your mind. With the help of this, easily you can explain about the change in color by adding the particular indicator in acidic and basic solution. I hope you have understand about the acid and base, ki what are acid and base, what are indicators, and what are the change in color of the indicator in the acidic and basic solution. Now after this I will be discuss about the classification of acid in my next video. Thank you. Good morning students. Today in this video I will be discuss about the classification of acid. That meaning how to classify the acid. We can classify the acid in many ways. Like firstly, if I will talk about the classification of acid, so one is there on the basis of occurrence. On the basis of occurrence, that meaning from which we are getting that acid. So on the basis of occurrence, there are two types of acid. One is the mineral acid, and one is the organic acid. Now second is there on the basis of, this is the first, and the second is there on the basis of strength. So on the basis of strength also there are two types of acid. One is the weak acid, and second is the strong acid, that is strong acid. Now after that the third way is there by which we can classify it. This is on the basis of amount of water. On the basis of amount of water, कि how much amount of water is available there. So according to that we can classify also in two ways. One is the dilute acid, and second is the concentrated acid, that is concentrated acid. Now the fourth point is there on the basis of hydrogen ion. So according to this, they are of three type. One is monoprotic, second is diprotic, and third is triprotic. So monoprotic, diprotic, and triprotic. Now if I will be discuss about the mineral acids, what are mineral acids. So that meaning the acid which we will get from the earth crust. That meaning from the minerals, they are called mineral acid. So whatever acid which will get it from the earth crust, they are called mineral acid. Like hydrochloric acid, HCl, this is a mineral acid. H2SO4, sulfuric acid, this is a mineral acid. HNO3, nitric acid, this is a mineral acid. Now the second part is there organic acid. Organic acid meaning acid which we get from the plants from the plants or animals. From the plants or animals, they are called organic acid, like formic acid. Formic acid, the formula is there HCOOH. Especially you have listened, whenever the ant sting is there and it bites us, then we will feel some irritation, because in the ant sting formic acid is present, which causes the irritation. The second is there acetic acid. This is acetic acid. The formula of acetic acid is CH3COOH, that we are getting from plants, and that is from the animals. So that meaning whatever acid which we get it from the plants or animals, they are called organic acid. Now the talk about the weak acid. The weak acid, what are the weak acids? The acid which ionize in less amount in water, or we can say that those are not going to ionize easily in water, they are called weak acid. Like CH3COOH is there. CH3COOH, if I am going to dissolve in water, so easily it will not ionize. It will take some time to ionize. Yeah, in less amount it is going to ionize. So that meaning the acid which will be ionized in less amount in water, they are called weak acid, like ethanoic acid, same formic acid, they are a weak acid. Now strong acid meaning those are ionized easily in water. As I am going to dissolve in water, they are ionized, that means they are converted into their ions. Like I am having HCl, if I am going to dissolve HCl in water, then on the same time it will be give us hydrogen ion and chloride ion, so it is going to ionize in large amount in water. So that means that is a strong acid. So these the weak and strong acid. Now I will talk about the dilute acid and concentrated acid. Okay, what are dilute acid? Dilute acid, that meaning the acid in which the amount of water is maximum. Amount of water is maximum. Amount of water is maximum, that meaning the acid is in less amount. The acid in which the amount of water is maximum and the amount of acid is in less amount, that are called dilute acid. So any acid we can make dilute, or any acid we can make concentrated. The second is the concentrated acid, in which the amount of water is minimum. Amount of water is minimum, that meaning the amount of acid is maximum there. So the acid in which the amount of water is minimum, they are called concentrated acid. After this, on the basis of giving hydrogen ion, there are three types, that is a monoprotic, diprotic and triprotic. If I will talk about the monoprotic, mono meaning one, so that meaning the acid which will give us only one hydrogen ion by dissolving in water, which give us only one hydrogen ion by dissolving in water, they are called monoprotic. Like HCl, this is the HCl, I am going to dissolve in water, it will give us H positive and Cl negative, that meaning only one hydrogen ion is there, so this is a monoprotic. Same, suppose I have HNO3, this is the nitric acid. If I am going to dissolve HNO3 in water, it will giving us hydrogen ion and nitrate ion, so this will also giving us only one hydrogen ion, so this is also a monoprotic. So that meaning very simple, the acid which will give us only one hydrogen ion by dissolving in water, they are called monoprotic. Now diprotic, di meaning two, that meaning the acid which will give us two hydrogen ion by dissolving in water, which will give us two hydrogen ion by dissolving in water, they are called diprotic acid. Like H2SO4 sulfuric acid, this is H2SO4, if I am going to dissolve in water, it will giving us two hydrogen ion and one sulfate ion, so this is a two hydrogen ion. So by dissolving in water, sulfuric acid give us two hydrogen ion, so we can say that that is an example of diprotic acid. The third is there, this is a triprotic acid. Tri meaning three, that meaning the acid which will give us three atom of hydrogen ion, they are called triprotic acid. Like suppose I have a phosphoric acid, this is H3PO4, this is a phosphoric acid H3PO4. By when I will dissolve in water, it will be giving us 3 atom of hydrogen ion and 1 atom of phosphate ion. This is a PO4 3 negative, which will give us 3 hydrogen ion, 1 phosphate ion. So it is giving us a 3 hydrogen ion. So we can say that this is a triprotic. Again I am telling you, the monoprotic meaning those will give us 1 hydrogen ion by dissolving in water. Diprotic meaning which will give us 2 hydrogen ion by dissolving in water. Triprotic meaning which will give us 3 hydrogen ion by dissolving in water. Same for dilute and concentrated acid. Dilute acid meaning in which the amount of water is maximum, that meaning we can say that the acid is in minimum amount, that is a dilute acid. Concentrated acid meaning the amount of water is minimum but the amount of acid is maximum, that is the concentrated acid. After that, weak and strong acid. Weak acid meaning which will be less ionized by dissolving in water. So if I am going to dissolve in water, it will be take time, or in less amount it is going to ionize in water. They are the weak acid. Strong acid meaning those will be ionized maximum. As I am going to dissolve in water, they will giving us their ions easily. They are a strong acid. Same for mineral and organic acid. Mineral acid meaning the acid which will get it from the earth crust or from the minerals, they are called mineral acids. And the organic acids meaning the acid which will get it from the plants or animals. So whatever acid will get it from the plants or animals, they are organic acids. The example I have given you here, formic acid. When ant will be bite us, then it will release the formic acid in our body. Same acetic acid, that is a CH3COOH. This is the organic acid. Now after this, the classification of acid, in my next video I will be discuss the physical and chemical properties of acid. I hope you understand the classification of acid. Thank you. Hello students. Today in this video I will be discuss with you peoples the properties of acids. In the properties of acids, first of all I will be discuss the physical properties of acids. If I will be talk about the physical properties of acids, so this will be the first physical property related to its taste. If I will be discuss about its taste, so all the acids, they are sour in taste. That meaning they have sour taste. So whatever acid you will be see, if you will taste it, so they are sour in taste. This is the first physical property of it. The second physical property that I will be discuss, one more thing is there, that sulfuric acid, whatever sulfuric acid or nitric acid are there, they are highly corrosive in nature. One more thing I am telling you, sulfuric acid, that meaning this is H2SO4, and nitric acid, this is HNO3. These two are very highly corrosive in nature, very highly corrosive in nature. That is why we are not going to taste these two acids. They are very highly corrosive in nature, so that is why we are not going to taste these two acids. Now the second property that I am going to discuss with you, this is effect on indicators. Second property is there, effect on indicators. That already we have discussed in my previous video with you people, but then also. So as we know that acid turn blue litmus blue litmus into red. Acid turn blue litmus into red. Its meaning is this: if I will put a drop of acid in blue litmus solution or blue litmus paper, then it turn into red in color. That is the effect on indicators of that acid. And the second thing is there ki methyl orange, that will be also there one indicator. Like if I am having the two more indicator is there, methyl orange and phenolphthalein. Two more indicators are available there. One is a methyl orange and one is the phenolphthalein. Methyl orange, if I will put the, as we know that the color of methyl orange, this is orange in color. So if I will be put the acid in methyl orange, then it will be converted into red in color. It will converted into red in color. So this is the also effect on the indicator. The second is phenolphthalein. I know that this is the colorless. Actually the phenolphthalein is colorless. If I will put it the acid in a phenolphthalein solution, it remain colorless. It remain colorless. There is no change in its color. So that are the main three indicators that I have discussed with you. One, I have indicated with you litmus, ki acid turn blue litmus into red. Second is methyl orange. Methyl orange, actually it is orange in color. If I will be add the acid in the methyl orange, then the orange color is converted into red in color. And second is there phenolphthalein. That actually color of phenolphthalein is colorless. If I will be add the acid in the phenolphthalein solution, then it will be remain as it is. There is no change in its color. That meaning it will remain colorless. Now after that I will be discuss with you people the electrical conductivity. That meaning the third property is there. This is electrical conductivity. Electrical conductivity. Electrical conductivity. Here I am using one word, that is acid solution can conduct electricity. Acid solution. Keep in your mind, I am using here word solution. Acid solution conduct electricity. Conduct electricity. This is, so that meaning solution meaning that should be in the form of water. Some water should be available there. That meaning hydrated acid can conduct electricity. Anhydrous or dry form of acid, they can't conduct the electricity, because in the dry form they are not going to release the hydrogen ion. So not release the hydrogen ion, that means they don't have any free electron, so they can't conduct the electricity. Now after this I am going to discuss with you the chemical properties of acid. The chemical properties of acid. Chemical properties of acid. This is the chemical properties of acid. Chemical properties of acids. In this the chemical properties of acid, there are lots of chemical properties. First of all I will be discuss the reaction of acid with metal. The first I am going to discuss reaction of acid with metal. Reaction of acid with metal. That meaning when an acid react with metal, then they will be form metal salt and release hydrogen gas. This is the general equation of this, कि when an acid react with metal, then they will be really form a metal salt and release a hydrogen gas. The general example I am going to discuss with you. Suppose I am having here hydrogen chloride. This is HCl, hydrochloric acid. it reacted with zinc metal, this is a Zn, then the metal salt, this is a zinc chloride, this is ZnCl2, and release hydrogen gas. To balance the equation, I will multiply by 2 here. This is hydrochloric acid and this is the metal. When metal react with acid, it will form the metal salt of zinc chloride because metal is zinc, and release the hydrogen gas. The second example I am going to discuss with you. Suppose I am taking here in place of HCl, I am taking here H2SO4. This is sulfuric acid. This is sulfuric acid. When sulfuric acid react with a zinc metal, then it will form the salt of zinc, because metal is zinc, so metal salt will form. So here zinc and this sulfate, they will react to give us zinc sulfate. This is ZnSO4 and release the hydrogen gas. So that meaning when acid react with metal to give us metal salt and hydrogen gas, whatever you have seen here. Here the main point is available कि the gas which is released, how to test for this gas कि the release gas is hydrogen gas. Lots of time this question they are asking in exam, and that is very important point कि name the gas which is released when a metal react with an acid, and how to test this gas. So very simple test is there. Now suppose I am having here a test tube. Suppose I am having here a test tube. This is a test tube, that is, and it is attached with a stand like this. Suppose this is a stand. This test tube is going to attach with this stand like this. It is going to attach. Suppose this is going to attach here in this way, okay, and here in this I am keeping the any acid. Suppose the hydrochloric acid is available here. This is the HCl I am using here, and from that side I am adding a zinc metal. This is the zinc metal, and here I am using a delivery tube. Delivery tube कि whatever gas will be released, or directly also you can do it here कि you will be use here. This is a test tube, and as we know that whenever acid react with zinc metal, it will release a hydrogen gas. So whatever gas will be comes out from here, as the gas comes out, you will take a burning matchstick on the mouth of the test tube. That I have taken here a burning matchstick. Burning matchstick. This is burning matchstick, and this is the gas. If the gas burn with pop sound, if the gas burn with pop sound, then it identify the gas is hydrogen. The gas is hydrogen. So this is the simple test to identify the gas is hydrogen or not. So we can say that the hydrogen gas burn with a pop sound. So that is very important for you people कि how to identify the test of presence of hydrogen gas. Now after this I will be discuss with you. The next one is the reaction of acid with metal carbonate and metal bicarbonate. Reaction of acid with metal carbonate or metal bicarbonate. Metal carbonate and metal bicarbonate. Reaction of acid. Reaction of acid with metal carbonate and metal bicarbonate. Now if I discuss the general reaction, so when acid react with metal carbonate, this is acid react with metal carbonate, then it will be form the metal salt. It will be form metal salt, water molecule, and carbon dioxide gas. This is now the same is there. Suppose the acid react with metal bicarbonate, then also it will be give us metal salt, water molecule, and carbon dioxide gas. So that meaning both the things will be give us the same product. The gas which is released, that is a carbon dioxide. This is the main point here. The example I am going to discuss with you people. Suppose I am having here HCl. This is a acid, and the metal carbonate I am taking here Na2CO3. This is now the metal salt Cl and sodium. So the sodium and Cl combine, then they will give us sodium chloride. This is NaCl, and the water formula is H2O. Carbon dioxide is CO2. It is a gas, that is why above one arrow I have indicated it. Now to balance this, I will multiply by 2 here and I will multiply 2 here. This is hydrochloric acid react with sodium carbonate to give us a salt of sodium chloride, the water molecule, and release the carbon dioxide gas. The same, suppose I have taken here metal bicarbonate. The same I am discussed with the metal bicarbonate. Suppose this is HCl. The metal bicarbonate is NaHCO3. This is the sodium bicarbonate. This Cl reacted with sodium to give us NaCl. That is giving us the NaCl. H and H2. Take one oxygen from here. This is the water molecule and release the carbon dioxide gas. So very simple. I will be say कि whenever the metal carbonate or metal bicarbonate react with acid, then they will form the metal salt, water molecule, and release carbon dioxide gas. That is a very important point here, which gas is released when metal carbonate or metal bicarbonate react with an acid. So we can say that they will be give us the carbon dioxide gas. Now how to identify the presence of this gas? What is the way to identify the presence of this gas? So that meaning test of carbon dioxide gas. Test of carbon dioxide gas. This is test of carbon dioxide gas. Test of carbon dioxide gas. Carbon dioxide gas. How to identify the gas is the carbon dioxide? The very simple again. I am going to take one test tube. This is a test tube, a gas cylinder I have taken here, and suppose this is a gas cylinder, and here I am going to take here acid. Suppose this is HCl. Whatever I have taken here, this is HCl. I am adding here sodium carbonate. Suppose this is the sodium carbonate. I am going to add it there, Na2CO3. The gas which will be released out, that will be comes in the form of vapor. This is a delivery tube, whatever I have taken, from which the gas comes out. And on this side I have taken a container. In the container I am taking a lime water. This is lime water, that is CaOH whole twice. This is a lime water, and I will pass out the delivery tube in the same container in which lime water is present. As the carbon dioxide gas comes, and it will be entered in this container in which lime water is present, then the carbon dioxide react with lime water, then it will be give us calcium carbonate with the water molecule. Calcium carbonate with the water molecule. So that lime water turn milky. Because calcium carbonate is milky in color, the lime water turn milky if I will pass out the carbon dioxide gas in limited amount. Keep in your mind, in limited amount. If the carbon dioxide gas is passed to the lime water in limited amount, then I will getting a milky color. The milky color is coming due to the formation of calcium carbonate. But if the same carbon dioxide I will pass out in excess amount, suppose the carbon dioxide gas is going to pass in excess amount, then these are to present here. Calcium carbonate H2O will be formed. So this calcium carbonate, or I can say that CaOH whole twice and CO2 is in excess amount, then the milky color is going to disappear due to the formation of calcium bicarbonate CaHCO3 whole twice. This is calcium bicarbonate, which is a insoluble substance. That meaning if I will pass out the carbon dioxide in limited amount, then the lime water turn into milky due to the formation of calcium carbonate. But if the carbon dioxide is passed out in excess amount, then the milky color is going to disappear due to the formation of insoluble calcium bicarbonate. So this is the test for the carbon dioxide gas. Generally you can write in this way also, कि carbon dioxide gas turn lime water milky. But if in exam they are asking कि due to the formation of which compound the lime water turn into milky, so that is a calcium carbonate. Or they can ask कि what happened when carbon dioxide gas is passed in excess amount in lime water, then you can say that the milky color is going to disappear due to the formation of calcium bicarbonate. I hope you have understand, child. There is no problem in this, the test of carbon dioxide gas. Now I am going with the next equation. This is reaction of acid with base. 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 That meaning acid react with base, so it will be give us salt and water. So that we have already read out, कि when acid react with base give us salt and water. So this whole reaction is known as neutralization reaction. The general example I am discussed with you. Suppose the acid is HCl and the base is NaOH. So the salt is NaCl. This is, and the water formula we know is that is H2O, which is left here H and OH. H and OH give us H2O. So that is the general example of reaction of acid with base, that means neutralization reaction. Now the next is their reaction of metallic oxide with acid. Reaction of metallic oxide with acid. Next is their reaction of metallic oxide with acid. Now the point is there, whenever metal oxide, whatever metal I have taken, metal oxide react with acid, then it will be give us metal salt, whatever metal salt will be there, that will be, and give us water, Now one thing keep in your mind, कि this is acid, and here is a metal salt and water. So what it indicate that, कि whatever metal oxide we have taken, they are basic in nature. That is why though it react with acid to give us salt and water, like neutralization reaction. So this indicate that कि metal oxides are basic in nature. This is also the important point here, कि what is the nature of metal oxide? They are basic in nature. Now, the reaction if I will discuss with you, suppose I am having the metal oxide, this is a sodium oxide, Na2O, this is sodium oxide. This sodium oxide react with, suppose acid is HCl. So the metal salt, the salt of sodium and chlorine, this is NaCl, and the water molecule is H2O. Same, to balance it, I will multiply by 2 here, multiply by 2 here. So sodium oxide react with hydrochloric acid to give us the metal salt and water molecule. Same, suppose I will be discuss the other example. I am having this is CuO, copper oxide. CuO reacted with sulfuric acid, this is H2SO4. So the metal is copper and its sulfate, this is SO4. So copper is react with sulfate to give us a copper sulfate, which is a salt, and release the with water molecule. So that meaning copper oxide react with acid to give us copper sulfate and water molecule. So that are the general chemical properties of acid. I hope everyone is understand about the chemical properties of acid. In my next video, I will be discuss with you the physical and chemical properties of base. Thank you. Hello students. Today in this video, I will be discuss with you the properties of base. That meaning how they will be react with the other things and what to physical property they are going to show. Before that, I want to revise you people what are bases. That meaning the substances which give us hydroxide ion by dissolving in water, they are called base. Like I have discussed the example with you there ki NaOH, when I will dissolve in water, it is giving us Na positive and hydroxide ion. So this is a base. Very simple, because this is giving us the hydroxide ion. Now the classification if I will discuss, then there are two categories of base. One is a strong base, and second is a weak base. It's also very simple. Strong base meaning which will be completely ionized by dissolving in water. That meaning which are completely ionized by dissolving in water. They are called strong base. Like NaOH is there, KOH is there. These are the examples of strong base which whenever I will dissolve in water, they will be give us, they are completely ionized to give us hydroxide ion. Now the weak base if I will discuss, so very simple, which are partially ionized, by dissolving water. They are weak base. Like ammonium hydroxide, this is NH4OH, or calcium hydroxide, etc. These are the example of weak base. Now that is a little bit revision related to base, their classification. Now I am coming on my main topic, that is the properties of base. In the properties of base, first of all I will be discuss with you people the physical properties of base. Physical properties of bases. So what are the physical properties of bases? The same, first of all I will be discuss with you about its taste. Simply, they have bitter taste. Simply, as we read out there in acidic, they have sour taste, but the bases they are bitter in taste. After this, I will discuss about it touch. That meaning feeling of touch. Its meaning how we will feel when we touch any base. Whenever we will touch any base, then we'll feeling of soapy touch. That is a feeling of soapy touch, or I can say that slippery, or I can say that slippery. They are very slippery in its touch. Now after this, the effect of indicators. The third is their effect of indicators. Effect of indicators, same. There is a litmus paper. As we know that ki base turn red litmus into blue in color. Base turn red litmus into blue in color, and base turn colorless phenolphthalein into pink in color. Colorless phenolphthalein into pink in color, and we know ki base turn orange methyl orange, that is orange in color, methyl orange into yellow in color. So that are the effect of base on the particular indicator. After that, same electrical conductivity. If I will discuss about its electrical conductivity, so same again I am using one word, basic solution conduct electricity. Basic solution conduct electricity. Basic solution conduct electricity. Again I am using a word here, solution. In the solution form they can conduct the electricity, in dry form they can't conduct the electricity. Okay, now after this the main point is there, the chemical properties of bases. Chemical properties of bases. Okay, what are the chemical properties of bases? Chemical properties of bases. Chemical properties of bases, very simple. The first is reaction of base with metal. Reaction of base with metal. Reaction of base with metal. Like acid, base also react with metal to release hydrogen gas. Like example I am discuss, suppose NaOH, this is a base, it react with metal. Suppose this is a zinc metal, this is, so it will be give us a salt of sodium zincate. This is Na2ZnO2, sodium zincate, Na2ZnO2 with the evolution of hydrogen gas. This is sodium zincate, and the reaction is very important. This is sodium zincate with the evolution of hydrogen gas. When sodium hydroxide react with zinc metal, it will form a salt of sodium zincate. The formula is there, Na2ZnO2 with the evolution of hydrogen gas. So we can represent in the above side arrow also. So this is the first chemical properties of base. After this, second property is there. This is a reaction with acid, that already we read out. Reaction with acid. When base react with acid, they will be give us salt plus water. Again, ki this is giving us a salt plus water, acid react with base or base react with acid. That means this is also a neutralization reaction. The example already I have discussed you with my previous video. Here you can see the base is NaOH, acid is HCl. So OH and H to give us H2O, Na and Cl react to give us salt, NaCl plus H2O. So that is, so the third is there. This is reaction of base with non-metal oxide. I'm talking about the non-metal oxide. Reaction of base with non-metal oxide. Reaction of base reaction of base with non-metal oxide. Reaction of base with non-metal oxide. Now, the non-metal oxide, I'm having carbon dioxide. I'm having a base, suppose this is NaOH. Non-metal oxide, this is a carbon dioxide, because carbon is a non-metal, so its oxide is CO2. CO2 is its oxide. So base reacted with carbon dioxide, then it will be giving us sodium carbonate. Means whatever is available here, base, according to that its carbonate will be formed. So this is sodium carbonate, formula is there Na2CO3, and after that they will be give us the water molecule. This is also a salt, this is a water, so this is base. So the non-metallic oxide, this is non-metallic oxide, so this is the base, salt, water. So that non-metallic oxide, they are acidic in nature, acidic in nature. So very simple. Before that I have told you कि metallic oxide they are basic in nature. Here I am telling you कि non-metallic oxide they are acidic in nature. Now after this I will be discuss with you some points related to bases, like alkali. Like alkali, कि what are alkalis? The thing I'm discussing about the alkalis. Suppose I'm having a base and I'm going to dissolve in water, and the base is dissolved in water. Base is dissolved in water, then I can say that this is alkali. So very simple, I can say that the bases which are soluble in water, or I can say soluble, water soluble base, water soluble bases are called alkalis, are called alkalis. Example in front of you, this is NaOH, which is soluble in water, KOH, which is also soluble in water, etc. These two are the general example of alkalis which are soluble in water. So you can say that water soluble bases are called alkali. Now sometimes they are asking in exam what is the difference between base and alkali. So very simple, all the alkalis, all the alkalis are base, because bases are alkali. So all the alkalis are base, but all the bases, all the bases are not alkalis, are not alkalis, because the base, only the base which are soluble in water they are alkalis, the base which are not soluble in water they are not alkalis. So this is the simple thing related to alkalis, and that is very important definition also in exam about the alkalis ki water soluble bases are called alkalis. I hope you have understand about the acid base, their physical and chemical properties. Now today in my next video I will be discuss with you the pH scale, ki how to find out the strength of acid and basic solution. Thank you. Hello students. Today in this video I will be discuss with you people the strength of acid and base solution, that's meaning pH scale. How to find out the strength of the given acidic and basic solution, that I will be discuss with you in this video. Now for finding the strength of acidic and basic solution, one word is there, this is pH. This is pH. The meaning of P is here, this is potent. The meaning of P is here, this is potent. Potent, its a German meaning is there, that is power, that is power. So that meaning power of hydrogen ion concentration. The power of hydrogen ion concentration, or I will say that pH is a number by which negative power of 10 has to be raised in order to express the concentration of hydrogen ion of the solution. That is the very simple definition, but I am going to discuss with you the other definition of pH. Now, what is a pH of a solution? pH of a solution. So this is pH equal to one formula is there, negative, this is logarithm, and this is hydrogen ion. Big bracket indicate that the sign of concentration, that meaning this big bracket, this will be indicate concentration. So I can define it from here only. The negative logarithm of hydrogen ion concentration, again I am speaking, negative logarithm of hydrogen ion concentration is known as pH of a solution. This is a very simple definition of pH of a solution. Now I am talking about the pH scale. What is a pH scale? pH scale. So a scale by which we can identify the strength of acid and base is known as pH scale. On this pH scale, some values are mentioned. Like suppose discuss about the pH scale. So on the pH scale, the values are mentioned from 0 to 14. Suppose this is a scale. This is one scale on which some values are mentioned, and here the initial point, this is 0, and the final point of this scale, this is 14. That means 0 to 14, and at the center it is available here 7. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. This is, so the 7 pH I'm talking about, this is a pH. This is a pH scale. pH scale which will indicate the acidic and basic nature. The solution whose pH value is 7, this is neutral. This is neutral, that means that is not the acidic or not a basic. And the substances whose pH value is less than 7, they are acidic in nature. They are acidic in nature. And the pH, the solution whose pH value is more than 7, they are basic in nature. So that is a very simple. With the help of pH scale, we can identify about the acidic and basic nature. They have their color also. If I will talk about, then this is the increasing order of acidic character, and this is the increasing order of basic character. So these are the things: increasing order of acidic character, increasing order of basic character. That meaning if the pH value is going to decrease, then the acidic character is going to increase. If the pH value is going to increase, then the basic character is going to increase. So that is a simple concept. Now after this I will be discuss about the same thing. Suppose the pH is equal to 7, then the solution is neutral. If the pH is less than 7, then the solution is acidic in nature. If the pH is more than 7, then the solution is basic in nature. So that is a simple concept related to as pH. Now I am discussing some questions related to pH, that is check out here. Like suppose I am having a solution which contain hydrogen ion concentration is 0.00001. This is, Now I want to find out the pH of this solution. pH of this solution I want to find. This is, so we know that the hydrogen concentration is this. If I want to write in a scientific notation in the form of 10 to the power, so what should be 1 2 3 4 5. So point I am going to shift it on 5 place here. So that meaning this is 10 to the power minus 5, because as the point is shifted toward the right hand side, the power will become in the form of negative. So whatever point I have shifted, that much of negative power will come. So that meaning hydrogen ion is 10 to the power minus 5. So the pH of a solution is known as minus logarithm of hydrogen ion concentration. This is the formula. So put the value of hydrogen concentration here. So minus logarithm. Hydrogen concentration is 10 to the power minus 5. Now here I am using one formula related to log. This is log m to the power n equal to n log m. This is the formula. Log m to the power n equal to n log m. That is the formula. The same I am using here. This is the minus. That is the minus. Now this is bracket. The power is coming because this is the power n. It will come in 5. Minus 5 is there, so that is a minus 5. Log 10. This is minus into minus. This is plus. So 5 log 10. The value of log 10 is 1. So 5 into 1. So its pH is coming 5. Because the value of log 10, that to keep in our mind, this is 1. So the pH of the solution is coming 5. So I can say that the pH is coming 5. That's meaning this is less than 7. So its nature, if they are asking, so nature of this solution is acidic, because the value of pH is less than 7. This is the one category of the question. Like that question they can ask in exam. The second category, if I will be discuss with you, that is very simple. Suppose they are giving us the 5 solution. The solution A, solution B, solution C, solution D and solution E. The pH value they are giving, its pH value is 8, it's 6, it's 9, it's 2, it's 7. That is the pH value they are giving us. Now they are asking the first question, strong acid. Second part they are asking strong base. Third part they are asking weak acid. Fourth part they are asking weak base. Fifth part they are asking neutral. They are asking which solution is strong acid, which is a strong base, which one is a weak acid, which one is a weak base and which one is a neutral. Now so we know that the pH value is less, then it is a strong acid. It is a strong acid. So first of all, I will talk about the neutral. The solution whose pH value is 7, that is neutral. So here whose value is 7, this is E. So neutral is E. Now check out the less than 7. Less than 7, they are acidic in nature. That is less than 7. So how many are here which are less than 7? One is B and one is D. One is B and one is D. The B pH is 6, D is 2. So we know that whose pH is less, that is a strong acid. So who's the less one? 2 is the less. So D is a strong acid and B is a weak acid because its pH is more than 2. The rest of pH is more than 7, which will indicate the basic nature. Now the more than 7 pH values are there. More than 7 pH values are available here. That is A values and the value of C. A is 8, C is 9. Now whose value is more? They are strong base, and whose value is less? They are weak base. So here which one value is more? 9 is more than 8. So the C solution having the strong base and the weak base is 8. That meaning this is A. So this is the way to tell us about the strong acid, strong base, weak acid, weak base, and neutral. One more thing I want to discuss with you people, this is pH of a solution is inversely proportional to hydrogen ion concentration. Keep in your mind, pH of a solution is inversely proportional to hydrogen ion concentration. That's meaning whose pH is maximum, whose hydrogen concentration will be less, and whose pH is less, whose hydrogen concentration will be maximum. This is, so keep in your mind, this is very important formula, because related to this in the exam they are asking the question, pH is inversely proportional to hydrogen ion concentration. Now I'm discuss the question with you people related to this, like suppose I'm asking the question in this way, what will be the effect on hydro pH value. The question is there, what effect does an increase in hydrogen ion concentration in a solution have on the pH of the solution, on the pH of the solution, very simple, you can check out the formula I have told you. The pH is inversely proportional to hydrogen ion concentration, meaning if the hydrogen ion concentration increase, then pH decrease. If hydrogen ion concentration decrease, pH increase. In this question they are saying that we are going to increase in hydrogen ion concentration. So what will be the effect on pH? We are going to increase the hydrogen ion concentration, due to inversely proportional, its pH value is going to decrease. So pH will decrease. This is the answer. The other way also I am going to discuss with you. Suppose I am having this container. Okay, in this container I am having some acid. Here the hydrogen ion concentration, this is suppose 20 hydrogen ion is present. 20 hydrogen ion are present. Now I am going to add it there 5 more hydrogen ion. So total are there 20 plus 5. This is 25 hydrogen ion. So very simple. The hydrogen ion is going to increase. That meaning acidic character increase. So acidic character increase, but it indicate that pH is going to decrease, because the pH is this is the increasing order, because 7 1 0 1 2 3 4 5 6, this is the increasing order of pH. So that meaning as the acidic character increase, because acidic character hydrogen ion increase, so acidic character increase. If the acidic character increase, so the pH is going to decrease. So that is very simple. By this also you can understand. I hope you have understand till this topic. There is no problem. Now the one more question I am going to discuss with you. Already I have discussed the things. Suppose they are giving us the pH values of 3 solutions. They are giving us the pH values of 3 solution. One I am having here vinegar. Second is Coca-Cola. And third is beer. 3 solution I have. The vinegar having the pH value this is 3.2. Vinegar having the pH value 3.2, Coca-Cola having the pH value 5.90, and the beer having the pH value 4.8. 4.8. First of all, they are asking about the most acidic. Which one is the most acidic here? Again, the point is here. They are giving the pH value. I've told you the minimum pH value will have the most acidic. So from here, which one is the minimum pH value? This is of 3.2. So most acidic is here vinegar, because it is having the minimum pH value from the given solution. Now the second point they are asking ki arrange these in order of increasing acidic strength. Arrange them in the increasing order of acidic strength. Increasing order of acidic strength they are talking. So increasing order of acidic strength meaning the stronger acid will come first. Which one will having the stronger acid? Which one having the minimum pH value? So which one is the stronger acid? Here minimum pH value is 3.2. Weak acid, which one having the maximum pH value? So maximum pH value is Coca-Cola. So this is a weak acid. I want to write the increasing order meaning firstly those having the minimum pH value. So which one having the those is the minimum acidic in nature, a weak acidic. So weak acidic is Coca-Cola because its pH value is maximum. So firstly what will come? Coca-Cola. After that beer, because its value is less than this, that is beer, and the most acidic is vinegar. This is vinegar. So this is the increasing order of acidic strength. Like that question lots of time they are asking in exam. One more question I am discuss with you related to the same thing. Suppose I am having A, B, C, D and E. The pH of this they are giving us 2, 5, 6, 1, 3. That is the pH. Now they are asking to arrange in the decreasing order of acidic strength. Decreasing order of acidic strength meaning first you will write that solution which one having the maximum acidic strength. Now first of all to check out कि here all the values are less than 7, so all they are acidic in nature. Now the maximum acidic whose pH value is minimum, that will be the maximum acidic. Whose minimum value is there? D. Its minimum value is 1 because 1 is the minimum value here. So D is the maximum acidic. So decreasing order meaning first of all I will write the solution who's having the maximum acidic character. So D is having the maximum acidic character. Please check out the sign. This sign is towards the D. Now after that A, 1 after 1 2 will come. So this is A, then 3 that is E, then 5 that is B, and then 6 that is C. So this meaning this is the maximum acidic and C is the minimum acidic because the D pH value is minimum, so it will show the maximum acidic character. The C, its pH value is maximum here, so it will show the minimum acidic character. So this is the decreasing order of acidic strength. Like that lots of questions they can ask in this way in exam. I hope you have understand about the pH, the strength and the question related to they are asking in exam. Thank you.